Okay, so this is what we've learned so far. We've learned that there is a strategy out there called isolation. You don't need to write this down. Okay, how do I know if I can use that technique? One variable type. Okay, so isolation is just called algebra, right? Move, over, collect, divide, that kind of idea. Okay, so then one variable type. So now the other thing would be, what if we have two variable types? Something like x squared and x going on in the equation. Okay, what do we do? Okay, before we do any strategy, what does the equation need to look like specifically? First and foremost, as soon as you have two variables, okay, equals 0. Then once we have that, we've now learned that we can do some factoring. Okay, and factoring, we've learned there's 4 styles that we look at. So you have to be able to recognize which style. So give me some names of styles. Difference of squares and simple, I heard. Complex trinomials and greatest common factor. Okay? So that's the gist of what we know so far. We're going to learn the next step later of what happens if it doesn't factor, because sometimes that will happen. Okay, but right now, if we have one variable, we can isolate, but as soon as we have two, must equal 0, try to factor. Okay, so here we go. Let's scan this page. Are there any of these, there's 8 of them, is there any of them that I can isolate with that strategy? Can you find, do you see one variable in any of them? The answer is yes, so where do I see it?
The negative x squared plus 9.
This one? Okay, so we can isolate it. So what do you want to move, collect? What do you want to do here, algebra? We could move that over there. So we could add x squared. Square root to get x alone. What's the answer going to be? It's not 3. Plus or minus 3, because you can square 3, or you could have squared negative 3. So you have 2 answers. Okay, is that important to have 2 answers? Yep. Because this quadratic, okay, it will hit the axis in 2 places, so that's important. Okay. This could have been done with a difference of squares as well. You could have multiplied by -1. Okay, and then do you see that that's a difference of squares? And that's why you're getting that plus minus 3 again. Okay, that's the only one I see, right? Isolation, can't do it anywhere else. Okay, so now we go to 2 variables. What did we say has to be going on no matter what? Equals 0. So do we have any problems on this page? This one is a problem. So let's change the look. Okay. Is there any other problems on the page? Yes, there's another one here that's not got to equal 0. Okay, so did you know that if I move this over like that, I don't like it? Do you remember me saying I hate the negative boss? Okay, so I'm actually going to keep the x squared, and then I'm going to move everything over there. Okay, there we go. So now we've done isolation recognition. Okay, if not, equals 0. Now let's pick our factoring. So number 1, do you recognize it as a style? Simple, right? Would you have said that? Trinomial, 3 parts, simple because it's a 1x squared. So bracket, bracket with x. So what are you thinking in your head? Multiplying to 20? And at the same time, you can get to 9, right, with an add. Okay, good. Next one. I don't like it. I hate a negative boss. This is the boss, and it's negative. So what should I do? What was a good strategy idea? Times everything, like giving candy to kids in your class, right? Everybody needs to get it timesed. Okay, it does not change your x-intercepts. All you've changed is the parabola going from down to up. Okay, that's all you've changed, but it's not going to change where they're crossing. So by timesing it by -1, this is all you've done. You've just changed the direction of the parabola, but guess what? These values are still going to be the same numbers, so that's okay. All right. Did you pick a style? Simple again, right? XX is the simple. Okay, you have to know your multiplication table here, what multiplies to 21. 3 times 7 would do that. Okay, next one. I don't really like this one too. It's kind of awkward for me. What's the thing I probably don't like? A fraction. So it's 5 divided by 2. So what could I do to fix that fraction? Just like how I kind of, yeah, same thing here. I multiplied everything by -1 to get rid of what I hated. So if I multiply by 2, and what are you going to do? Make sure you're doing it to all things. Okay, so 2x squared. What happens to that fraction when you multiply it by 2? Just 5x now, right? Because it had a divide by 2, and now you're timesing it by 2. That's just a cancel of it. Plus 2. Okay, now factoring. So I thought, well, what's the style? Did you recognize it's a complex? Okay, so it has to multiply to 4 and add to 5. My numbers that I'm kind of working with are going to multiply to plus 4. Where did I get that from? The FLA. I call it my FLA number. It's not really a technical term, but that's just what I do. And add to that. Okay, so let's talk about this. How could you make this in your brackets, the F? You need 1x times 2x. That's the only way to make that in a bracket foil. What's the only way you could L to this? 1 times 2. Okay, so now your puzzle connectors on the O and the I. what are they going to do? I have to connect to make a 4x. So that's going to multiply to be a 4x and a 1x. Sorry, I guess we didn't pick our numbers here. Right? What multiplies to 4 and adds to 5, right? Okay, so now I feel like most people are good at that, but then forget how to connect them. So brackets, you gotta understand foiling, because we're doing backwards foiling, right? So 1x times 2x, that's my FF. O connectors, I connectors. I want the 1x to connect to a 1, 2x to connect to a 2. Why should you never have an error when you factor? What can you do to make sure you are right? Quickly FOIL, right? You're really good at foiling, okay? Factoring is a little tricky still, but you're really good at foiling. So 2x squared, check. 1x there, plus 4x. Oh, check. What's my L times my L? Check. Okay, it's just a quick scan. You should be able to figure out if you did it. Okay, and your x is always opposite, divide. Okay, before we didn't have that because opposite divide was just a 1 divide. Opposite, and we don't have to divide by 1. Okay, so this one, we've already fixed the problem. We decided that one wasn't 0. Okay, what multiplies to 6 and can make a 5? So this one is tricky because there's kind of 2 options, because 1 times 6 could get me to a 5. 2 times 3, okay, well that could also get me to a 5. One of them is correct. Think about it with the signs of positive and negative. So go ahead on your own. Make sure you're thinking about how the signs are going to be working here. So you're deciding if you're picking the 1, 6 or the 2, 3. Okay, so here's what I always tell myself. If this multiplies to positive, it tells me they're both the same sign. So now how do I get to the negative 5? Same sign. So did you pick the correct set? So if this said subtract 6 at the end, that would have been the other set. Okay, so 2 tricky things on that one, the 0 and then the almost 2 options. All right, so this one is a simple trinomial, but it's just a fourth and a squared instead of a squared and a single. Okay, but we're going to do it the exact same way. So FF, how do you get to an x to a 4th degree? X squared and an x squared. How do you multiply to 36 and add to negative 5? Oh, there's more work to do. Do you see the more work? This one. This one is a difference of squares. So x plus 3 minus 3. What do you know about this one? It is not factorable. Do you remember that? Why isn't it factorable? Think about what would x squared need to be worth to make a 0. What would you need here? Something plus 4 makes 0. What would you need here? You would need it to be -4, right? What are you going to square to make -4? Nothing. It's never going to work. So there's no answer to it. So then if there's no answer to it, it's not factorable. So we leave it alone, but we can answer here. Those are answers. Okay, but this will not give me any more answers. Okay, we had one exactly like this yesterday, so this one should be okay because it was on your homework as well. What's your first move, though? Do you remember your first move on this one? GCF. Okay, by the way, GCF is always your first glance. Do I have it? Because if I have it, it has to happen first. Okay? So there's 3 terms. They all have an x in common factor. So if there's 3 terms, you better have 3 distributions. Okay, and this question is one where there's more work. It's not just a one-step factor, there's more factoring. So now this is a simple trinomial there. Okay, but please make sure you keep the x in the front. So you have to get to 42. Again, multiplication facts, they're in your brain, right? If you are a person who's always jumping to your calculator to be like, oh, what multiplies, okay, that's going to be too long of time. You got to be a little bit faster knowing, oh, that's 6 times 7. Okay, do you understand there's 3 answers here? 0, 6, and 7. Okay, it is a cubic, so that's okay to have 3 answers, right? Quadratic, there's often 2 answers, right? Okay, so that was a little bit different. All right, last question. So again, I just don't like this. So what's the thing I probably don't like? Fractions. So this one has a fraction with a divide by 2 in it. So I could times all by 2 to get rid of my thing I don't like. Okay, did you revamp it? This stays at 0, right? 0 times 2, that's good, it stays. Okay, so this is a complex now. Good, it's a complex. We are going to do what? Multiply to -6 and add to -5. Okay, this is that tricky one again. So, this is the one that's tricky. What multiplies to 6? Okay, so which set is going to work according to the signs that I need? I'm going to have to pick this one because they're going to have opposite signs of each other to be -6. Right? Okay, so let's talk about our options. So how could you make a FF out of that? How could you make an L foil parts? What could you do to be in your LL? Okay, what's your puzzle connectors to make your O and your I? Puzzle connector, 2 to the 3. Okay, I already started with my FF. So the X and the 2X are in the FFs. Okay, O. The 1X has to connect to a 1, and the 2X has to connect to a 3. Quickly scan by foiling it out. Does it do what you want it to do? F times F, check, 2x squared. O plus 1x, I subtract 6x, negative 5x. What's the L times the L? Good. Okay? Please do that. There's no reason to ever factor incorrectly when you can scan it like that to check, right? And are you answering with an opposite value? And sometimes you have to do opposite divide, right?